Okay, let's get started. Gwen Shapira, I'm a committer on Apache Kafka. I work for Confluent, which is a company that was started by people who originally developed Kafka way back at LinkedIn. I'm not going to talk about anything Kafka related at all, because I spent really large parts of my career either being a software architect or advising software architects. I used to say that, hey, I don't have my title here because then you want to believe the rest of my talk. But now it's even worse. I'm an engineering manager. So just so I'll know how many people I'm going to insult in the next half an hour, how many of you are software architects? 1, 2, 3. Okay. So if you are a software architect, you probably know what your job is and what it is you do. It may surprise you to discover that the rest of the world really doesn't. So we're going to talk a bit about that. And the first thing you need to know, this is not a lie. We do have a real job. And the job is basically to get engineers across, usually in very large organizations, to standardize on things, to kind of agree and kind of do things in the same way. It's good for the organization if there is a certain set of tools, methods, languages that everyone can agree on. So you try to get engineers to cooperate. There is a huge problem with that. And this is that engineers generally do whatever it is they want to do. And the reason is that they work for managers who have every incentive in the world to let them do whatever they want to do. Now I really know that. It's really hard to hire engineers, and it's really hard to make sure engineers are happy and productive. And as a software engineering manager, this is literally your only role. This is what your manager will ask you. Is your team happy? Are they shipping software? Are they shipping it on time? Do they feel productive? So this is huge, which means that if an engineer goes to you and says, I want to use Go, you say, sure, use Go. And if an engineer says, I want to use Kubernetes, sure, whatever. If an engineer says, I want to use REST APIs, of course. You want to use gRPC, that's the cool new thing. Yes, go use gRPC. I have absolutely no incentive to tell them no. The problem is that there is a lot of such teams across the company. I just learned that they each contain more or less 5 people. And if half of them uses REST and the other half uses gRPC, our entire microservices plan is going to fall apart, right? Because the whole point is they have to communicate to each other. So you need to have some kind of a standard. It also helps if there is like maybe, I think Google says it's one language for every 5,000 engineers. So we try to do that. But it's kind of hard. You can't really force software engineers to do things because, as I just said, they have all the power in this relationship. So what you have to do is to convince them to do things your way, which of course means that nobody knows what software architects do, because if you do a fantastic job, it looks like you did nothing. Everyone just did whatever they wanted to do, and it just happened to be the exact same thing across 20,000 engineers of a large organization. Sure, but the thing is that to convince engineers who tend to be smart and opinionated, we just heard a lot of opinionated from smart engineers, you have to be very convincing. You have to have maybe proof. You may have to do proof of concepts and maybe measure things. You have to do some research. You have to have debates. You have to have those conversations, really compelling designs, good reasons. This is ridiculous amounts of work. So we take shortcuts. And we may make things up because we want to believe in some things and we want to convince people of things, but actually doing the research and the debates and testing and everything that it takes to actually have good convincing proofs is hard work. So shortcuts have been made, and in the last maybe 10 years of working with software architects, I heard a lot of those lies. And I want to share some with you because some of them are repeating and it kind of helps to know what the actual truth is. So because I work on Apache Kafka, which is sometimes used as kind of a speed layer or a fast data layer, I hear this one a lot. And if you're very naive, you may think that if someone tells you I'm building a real-time system, they're building something like that. It takes a lot of naivete, and the real thing you have to do is to ask, well, how fast does it actually have to be? And then you find out, oh, it should be, the dashboard has to be refreshed in no less than 15 minutes. So, okay. And this has a slightly older cousin. I used to work on Hadoop. So between 2012 and 2016, this was my life. Everyone had big data. And usually this is a reason to choose kind of a very unknown, untested data storage system. And you ask them, why do you use MongoDB? And they say, well, we have big data. Why do you use Spark? Well, we have big data. And sometimes it is the right technology, but sometimes you find out that they have 45 gigabytes of something. So the truth is that we don't have big data, we don't have real-time data. What we really have are requirements. We have the things that our system actually is supposed to do. And those big data, fast data stuff is a shortcut, maybe known as a lie. And it basically obscures the fact that there is actually something that you want to achieve. And if you use those things, you will never know if you achieved it or not because you never articulated what it is the thing that you actually want to achieve. So in case you've never seen them before, it happens in some organizations, this is what normal requirements look like. We need that many megabytes per second, latency from this point to this point should be that many milliseconds, availability should be that many nines measured with this thingy, storage, etc. So those are actual requirements, but no less important, actually a lot more important, there are some soft requirements. The things that nobody will actually tell you, which is why architects work best when they've been in the organization for a really long time, and they kind of know what happens to someone who takes a risk and fails, what happens to someone who is the first to introduce a new technology that may or may not actually deliver. And this is way more important. If you say that I'm going to build a system that can do 500 megabytes per second, and it turns out to do 480 megabytes per second, you'll probably get to keep your job. It's going to be fine. If you misjudge the organization tolerance for failure, and you introduce a new technology, it doesn't work as expected, you try a lot of times, after half a year it still didn't work, and everyone's like, why are we not in production yet? And you misunderstood what the organization is about, this is usually how architects lose their job, not because they didn't fit the throughput requirements. So this is really the big one. Now, it may seem to you like I hate all buzzwords. It would be correct, 100%. Buzzwords are not exactly lies, but they have stuff in common with lies, which is kind of a mental shortcut to avoid the hard work of understanding what is your actual requirement and what does the system actually deliver. So I gave you a convenient shortcut translator. So if someone tells you something about the system, you can kind of have an idea what they're trying to get at. And then you can check, is this something that I'm actually looking for? And is this something I'm actually after? Now, one word of caution is that when if you go to someone and ask them about requirements, and they say, oh, my big data is 45 gigabyte and my low latency is 15 minutes, you are not allowed to laugh. They tend to be incredibly sensitive about that. And I've had cases when I looked at someone's requirement and I said, oh, you need to do that, fantastic, that's easy. And what they heard is that if it's easy, it's probably because something is wrong with them. They don't have big data. You are never allowed to laugh at someone's data size. But what I want to say is that it's good that things are easy. It means that we can build a cheap, stable, simple system. It's not that common that you get to build something that is cheap and simple and stable. So you kind of enjoy it when you find out that your requirements allow you to do that. And the real thing to remember is that there is nothing wrong with discovering that your requirements allow you to build a system, a simple system. Nothing wrong with discovering that, oh, I can meet the requirements on a MySQL instance running on AWS smallest and cheapest machine. This is actually fantastic. Now, next slide that I heard quite often, more in recent years, is that hybrid and multi-clouds don't exist. Now, don't exist is an absolute lie. I know that because I worked on maybe 10, 20 of those. I have one of those on my own. So I'm not saying it's easy or it's recommended or that you have to, but they definitely exist. Now, there is a big cloud conference from a major cloud vendor that goes around basically banning any talks that has the word multi-cloud in it from even appearing. And because it's one of the biggest conferences in the world, I cannot really blame a huge number of people who believes that this thing does not exist. But if you get all your information from a single vendor, you may be slightly out of touch with what reality is. And at the very extreme case, I run into people whose architecture is basically a copy-paste of some kind of a vendor talk. And you can tell because it have every single component that the vendor is selling. So I'm landing data on Kinesis, and it's going through a fire hose, landing on a street, triggering a number of the functions that load it in the Redshift. And then you kind of look at it and say, well, why can't you land your data directly on S3? Why do you need everything else? You can just write to S3. And I've never gotten an answer to that. And I suspect it's because you cannot have the conversation. If someone did not come up with the architecture, if they didn't think about it and reason about it, how would they be able to answer this question? So you cannot reason them out of it. The only solution is to get there first. So please, everyone, take out your phone, and this is the right architecture to copy-paste, please. It's fantastic. It has a lot of benefits. It has some drawbacks, but I mean, you don't really want to discuss it, right? That's why we copy-paste architectures. But more seriously, I mean, if you look at what cloud vendors say, on one hand, they say, don't do multi-cloud, don't do hybrid cloud, this is expensive, it's too hard, it doesn't work. But on the other hand, they say, hey, there is no lock-in. You cannot have both at the same time. One of them is not true. So please, there's nothing wrong with using a single cloud vendor. Actually, it's a good idea for many reasons. It makes things simpler, a lot of things are cheaper, you have less ops. It is a good thing, but you have to know that one day you may need to go somewhere else for reasons that you may or may not choose. One day your management may decide that, hey, it will save us money to go to our own data center. It happened to Dropbox. So you want to have a plan B, and you want to make sure that by whatever means you build it, make sure that you always have an idea of how to move a cloud. Even if you don't implement it, you kind of have this thought of how to do it. You're not locking yourself in your mind. Okay, totally different lie. This is not 100% a lie. It's sometimes true. There are sometimes organizations who did microservices, and they're happy with it, and everything is fantastic. All power to them. But very often, it's not true. Sometimes the truth is that we're trying to be microservices. Unfortunately, we also have this big mainframe in the back rooms that we try not to talk about in big presentations. And you know what? This is fine. Being aspirational is fine. Having a 2-year forward-looking plan is also fine, especially if you admit the common truth about all architectures is that they're never static. They always change. And one may even say that all reality always changes. Nothing is persistent forever. So you can see architectures as kind of those Buddhist mandalas. It's like these amazing works of arts drawn in the sand, only to be swept away and redone. And don't get too attached to your current architecture, because we all know that in a year, 2 years, it will be something completely different. Maybe it will be serverless, maybe it will be AI, maybe AI architectures will be the next cool thing. Those is all fine. Those are really good lies to tell yourself that our architecture will last forever. It can get worse. What if your truth about microservices is that you have 50,000 microservices, you have no clue what you have and where it's running and why it's running, you have no idea how they're talking to each other. The simplest change ever changing one config requires stitching a workflow across at least 6 different microservices and 15 different teams. You haven't been able to deploy anything in 3 months, and don't even talk to me about troubleshooting. If this is your truth, then you may be maintaining a distributed monolith. It happened to a lot of companies who either tried to build microservices from scratch or migrated there, where microservices did not deliver on their promise. So how do you know if you are living in distributed monolith hell? It's really easy. Microservices made a promise. They made a promise of localized changes and localized deployments. Look at your system. Do you actually have them? If you do, then you don't have this problem, and all power to you. I would please tell us where to send all our CVs. But if a tiny change requires changing a lot of microservices, if you have dependencies on order of deployment, if one machine crashes, impacts everything else in its vicinity, then maybe you are actually living in a world with a distributed monolith. And the biggest offender there is the idea of responsibility leakage. The idea that logic from one microservice leaks into a lot of others. And my classic example is that you have an insurance program, and you know that every time you move to a different location and you live somewhere else, you need to get a new quote because your car may or may not be more or less likely to be stolen at your new location. And the way you implement it is you make the customer profile call the insurance quote service every time there is an address change. This is quite bad because now the customer profile has to know something about how quotes are done. And it's kind of leaks there, and now changes about the insurance quote service actually gets distributed across multiple of those services. This is my place to highly recommend looking into event-driven microservices, where the idea is that each service publishes events, publishes things that happened. Someone changed the address, someone changed the phone number, and you don't need to know who cares about it. You just need to let everyone know it's happening. And then the insurance quote service can listen to all those events and say, oh, someone changed an address. I know I have to react to an address change, but not react to a phone number change and not react to an email change, which is exactly where you want. So now the insurance service, quote service owns all its own logic, and all the customer profile service has to do is publish events. I really like those. Of course, don't copy-paste that, right? But a nice thing to look into. I'm a big fan. Okay, another line, number 5. Architects say we use best of breed. And that's a problem. I mean, it sounds democratic, it sounds fantastic. I use the best of everything, but the truth is usually that we use one of everything. And that's exactly the problem I talked about in the beginning, right? Developers want to use Go and gRPC and REST APIs and this framework and that framework and Helm and Terraform and Pulumi and whatever else. It's exactly what architects were hired to prevent from happening. So if you have one of everything, it's more or less saying, I'm not actually doing my job, which is not the best thing to say. Obviously, so the idea is that there is a cost to owning something. And the more technologies you own as a team and as a company, the costs accumulate. You need to learn it, you need to learn how to deploy it, you need to learn all the bugs, you need to learn how to monitor it, etc., etc. This is not sustainable, and there is a nice graph to demonstrate how it's not sustainable. Note that the costs keep increasing because all those technologies have to integrate with each other. And by the time you add technology number 20, it has to integrate with 1 to 19. It just gets harder and harder. So yeah, the graph is maybe not the most scientific, but you get the idea is true. It has born from experience. Now, if you do too much of that, though, if you only worry about not increasing your basically technical inventory, you end up in one of the worst anti-patterns ever, which is that only architects get, if you're the architect, and it's your job to basically sign off new technologies in the organization, shouldn't you be the only one exploring new technologies? And the answer is, God, no. This is terrible. It makes life terrible. It's terrible for engineers because they don't get to experiment with new technologies, which, to be fair, is the most fun part of our job. But it's also terrible for architects because the architect job is to have some influence. And it's really hard to influence people to try things when you are the only one who is looking into them and when they feel like you are forcing technologies on them. So they will probably resist you, and now your job is that much harder. The better pattern, and this is something I learned from my customers, is that there are some cultures in some companies where all the engineers continuously experiment with new technologies, and the architect's job is kind of direct some of that, give people ideas, tell them, oh, you looked into that, but did you also check ABC? Can you run this load test? Can you run this scale test? And once something has been implemented successfully in one part of the organization, help it kind of seep into the rest of the organization. Help the engineers evangelize it, put up the word, help other teams adopt it, and that's how you create sustainable standards. You don't force engineers to adopt what you came up with. You found something that the team was already successful in, which means that you have your proof, much easier to convince, and you help them convince other teams that, hey, this is really good, and 18 months later, the entire organization uses this something because it worked really well. This is really fantastic, and because you're not the only one doing new technologies, you have this force multiplier, so you can actually use the teams that adopted it and wants to evangelize it to build tools, to build technologies, to help us write documentation, help everyone else. A company that did it incredibly well is Lyft. I was at their talk about how they migrated from REST APIs to gRPC. And the talk was not about the benefits of gRPC over REST APIs. That was like the first 5 minutes. The rest of the 40-minute talk was around how they did immigration, which involved a lot of tooling. It involved writing a CURL for gRPC, writing a proxy so everyone could migrate in their own time. They had all those really amazing things. So this is a great pattern. And don't tell me that it's good for Lyft, but it would never work at my organization, because the last lie is that this is absolutely BS. I've heard that so often. We cannot do event-driven microservices. We're an insurance company. We cannot do cloud. We're a bank. Like, haha, very funny. The truth is that I know, 20 banks that do cloud. So just because you're a bank does not mean you cannot do cloud. I know 100 insurance companies that did microservices. There is absolutely no reason why you couldn't. And I was actually in a hilarious conversation. I think it was at QCon New York, where a lot of banks kind of hang out. And someone actually said, well, we're Bank of America. Of course, we could never do cloud. It doesn't have all those things we need to run a bank. And the other guy was like, well, I'm Capital One. I'm also a bank. And guess what? We're totally in the cloud, and we're seeing all those amazing benefits. And the other guy was like, hey, I'm JP Morgan Chase. We're actually 2 banks, and guess what we're doing? So it's really like your industry is usually not an excuse. And sometimes I worry that the real truth, if you say things like that, is that you don't want anything to change. And this is incredibly worrying, because being an architect is all about enabling change, enabling the development teams, enabling the entire organization to adopt new technologies. If you want nothing to change, you should probably be like a sysadmin or something. So I think there is really something that the world keeps changing. We have no choice. We have to change with it. And I think that taking on the role of how to enable companies to change safely and in a way that the entire organization can absorb is actually the big role of an architect. Like, this is the thing. How many new technologies can we absorb in a quarter? How do we adopt them safely? How do we get there? How much proof do we need? And what are the best practices? How do we enable everyone to learn those best practices? And the key is that you have to know your org. That's why you have to be kind of experienced in order to be there. And you have to know that every organization can take some risk. And the level of risk it can take actually kind of comes and goes, maybe multiple times a year. There's points in time when everyone wants stability, and then points in time where everyone wants to move faster and do cool things. And you have to have your handle on you have to feel the pulse of the organization. You have to talk to product and executives, and you have to really know when is the right time to do bold moves, and when is the point with the most impact where you can do bold moves. Don't waste those precious risk points and credibility points to do something that doesn't matter and has no influence. So, for example, we used Kubernetes when it was very early. I feel like it was a mistake because we used so much of our availability and pager points on something that will never be our core strengths, where we should have used it to do cool things with Kafka, which is our core strengths. So you really want to assess where is the right place to place your risk chips, and then enable the entire organization to kind of, as a wave, kind of go after that, kind of steering your ship kind of thing. Too many Kubernetes metaphors. So just to sum things up, all of this kind of ties together. If you want to be an awesome architect, you want to not lie. You want to collect requirements, you do tests, and of course it's a lot of work to do on your own, so you want to work with engineering teams to really enable those experiments, make sure they're successful, and be a change agent for your entire organization. And since it's the end of the year, it's time for resolutions. Maybe you are currently an SRE or an engineer, and you're thinking, this sounds really good, I want to do that, and in 2020 you'll become a software architect. Or maybe you're currently an architect, and I just inspired you to be a better one in 2020. So I hope we'll all go out and have an amazing year.